Welcome. Well, let's see. This problem, it says to use a conjugate to rationalize a denominator. Well, let's go read through this word problem first. The area of a rectangle at the right is 900 square feet. What's the area of the rectangle? Well, we should know by this stage of the game that the area of a rectangle can be defined as the length times the width. So we'll make a little better A right there. All right, write and simplify an equation for L in terms of X. Well, I see the rectangle, and there's my width, and there's my length. And I have no values for that. Now we're trying to solve in terms of L, because we already know what the area is. It's 900 square feet. And then I'm sitting here looking at this thing, and I'm going, why is this triangle, this 90-degree right triangle, sitting out here? And you know what? If I dip back into what hopefully we know, in terms of trigonometry, we could actually find this little piece right here, and then we could define our area. Let's say 900 feet, square feet, is equal to the length times the width. I still don't know much about the width, but it could be this piece plus X. So I see this right triangle here, and here in the base of this, or actually the adjacent side to that 60-degree angle, is 12 feet. Now thinking about this as a right triangle, well, this is the opposite side right here, this section right here, and this is the hypotenuse. And it's a 60-degree angle. Now, I might remember from my special right angles of a 60-degree triangle that whatever that measure is of that adjacent side, when I'm dealing with a 60-degree special angle, then that is, this opposite side is L times the square root of 3. And the hypotenuse is actually 2 times L. All right, so I think that's what I know, but I'm going to set out to kind of prove it, and I'm going to do it on the calculator, just kind of talk your way through it. And if I'm thinking about SOHCAHTOA, 90-degree triangles, the tangent is the opposite over the adjacent. So if I had the tangent of 60, which is equal to the opposite, which I don't know, I'm just going to label it O, or let's say OPP, so I don't confuse it with a 0, over 12, then that opposite side is equal to 12 times the tangent of 60. All right, so I put in 12 times the tangent of 60. 12, I want to make sure I'm in degree mode first because my angle measures in degree, and I see that I am, times the tangent of 60, and hit enter, and I get this weird number, 20.7846096. Looks like an irrational number. But I think that should equal the length, L right here, I should say this leg, I should say leg, L, not length, L, the leg of 12 times the square root of 3, and let's divide this this irrational number, 20.785, let's divide it by the square root of 3. And hopefully that's going to be 12. And shazam, it is. So this piece is 12 times the square root of 3. That means that this hypotenuse, this is just an aside item, should be 24. You know what? I think I'll prove that with Pythagorean theorem. So Pythagorean says that the two legs squared added together equals the hypotenuse squared. So let's see, if I took 12 squared, that's 144, plus 12 times the square root of 3, that would be 144 times 3 for that opposite leg. Let's see, 144 times 3, that equals 576, and that would be the hypotenuse squared. So if I take the square root of that, square root of 576, hopefully that's going to equal 24, and it does. Okay, so I have proved what I thought I knew about a special angle 60-degree right triangle, that it is equal to the adjacent side being the leg, opposite side being the leg times the square root of 3, and the hypotenuse is being equal to 2 times the length of that leg. Well, now I can define W as 12 times the square root of 3 plus x right there. And we're going to try to solve this for L. So let's see, we got 900 equals L times 12 square root of 3 plus x. All right, well, that's L times that, so I can divide 900 by 12 square root of 3 plus x. So now we got 900 over 12 square root of 3 plus x. And that's actually equal to L. But you know what? I've got a radical in the denominator. And what are we talking about doing? Use a conjugate to rationalize a denominator. So the conjugate of 12 square root of 3 plus x is 12 square root of 3 minus x. And so if I multiply this rational function with a radical in the denominator by its conjugate, I should be able to rationalize that denominator. So let's see, we got 900 times 12. 900 times 12. That's 10,800. Square root of 3 minus 900x. 900 times 12 square root of 3, 900 times negative x. And now that's going to be over, and let's rationalize this denominator. Well, let's see. 12 times 12 square root of 3 times 12 square root of 3. That's going to be 144. Well, let's write it out. 144 times the square root of 9. And then I've got negative x 12 square root of 3, and then positive 12 square root of 3. Those are going to cancel. And then I've got plus x times negative x, and so that is negative x squared. That still equals L. And I can simplify this just a bit by this 144 times the square root of 9. That's 144 times 3. So let's see, because square root of 9 is 3. 144 times 3 equals 432. So in terms of L, in a rectangle is 10,800 square root of 3 minus 900x over, what did we say 144 times 3 was? 432. 432 minus x squared. Well, that's quite the problem. I really enjoy problems like this. Look what I had to think back on and reflect on. I got my toolbox here. Part of my toolbox is a little bit of trigonometry. And with that little bit of trigonometry, I can solve this problem. I can simplify an equation for L in terms of x in this case. And so my width is 12 square root of 3 plus x, whatever x is. Not sure what that is. But if I get a value for x, well, actually now we could sit here and, if I wanted to, we could actually find what x is. But you know what? I'm good with what I've been asked to do. I don't want to complicate it any more than that. What about you?